Okay, so hey guys, it's 13 February and let's do the daily Leetcode challenge for today. And let's see what we got. Okay, so we have the minimum operations to exceed threshold value part 2. Let's see. You're given a zero indexed array nums and an integer k. In one operation, you will take the two smallest integer x and y in nums and remove x and y from nums. Okay, take the two smallest numbers and remove them from the array and add this value into the array anywhere. Okay. Note that you can apply only the described operation if nums contain at least two elements. Here, at least two are needed, and return the minimum number of operations needed so that array all the elements of the array are greater than or equal to k. Okay, so we need to repeatedly uh, apply this operation onto this array until then the smallest number is actually greater than this value k. This is the threshold basically. So if we think about it, basically a really simple question that we are given an array. Fine. We will take the two minimum values out of it. So we have to firstly see how can we take the two smallest values out of it. There's a really good thing about it, a good approach to do it. Okay, let's see. We take two smallest value out of it. We remove them, and from these two values, we will form a new value, which is basically this minimum of xy into 2 times plus maximum of xy. So this we will form this and we'll add this in the array. Again we will do until then. कब तक करना है? Until when? Until the smallest value out of this array is greater than k, which is a given value. This is a threshold. Okay, until then we need to go. So one way of doing it is, that's obviously not a good approach, but we sort the array. We take the initial two values because these will be the two smallest values. We take them, we remove them from array, and we basically add a new value which can be found with these two values. Okay, after adding that value we will sort it again, then apply the operation again, sort again, apply the operation again. We will see how many number of times we need to go for it, because every time our operation is applied one element is decreased. Okay, what happened here? I don't know what happened. Yeah, whatever. Okay, whatever. So that's what we need to do, right? Every time a operation is applied, one element, like the size of the array, decreases by one, right? So minimum two size array is needed for this operation because two elements are needed. So yeah, it's greater than two always. So what we can do here is, see, that's the one of the approach. That's how we can do it. Okay, what can be the optimal approach to this? Because that's not good approach, because every time we are sorting it and we don't know how many time we need to put on the operations. Okay, so that's not a good approach. So that's pretty simple to think that if we want minimum values every time from the array, what can be helpful to us in that case? Which data structure gives us the minimum value in constant time and in element insertion into it also in log in time? That's the heap. To be more precise, min heap. Okay, min heap gives us the minimum value in constant time and we insert it, it's take log in time. Okay, so that's the most optimal data structure we can think of for this kind of question. So yeah, we will take only that. We will take a min heap. Okay, nums dot size. Fine. And the constraint, if you see, is 10 raised to power 9. So basically the elements are greater than int. So we are going to take at least long. Okay, so Priority queue is used to implement min heap in C++, and it will be a min heap, so it will have a quite bit different syntax. It's not simple that priority queue int pq, that's a syntax for max heap basically, but for min heap we will do it like long long greater of long long and vector of long long. This is how a min heap is implemented in C++. So we will just iterate through this array and insert all the elements inside the heap. So it will be pq dot push I. All the elements are inserted in the heap now. So if we take out the elements from the heap now, it will be from the top of the heap, which gives us the minimum value of this whole heap, which is basically the array. Okay, because we have inserted all the element of the array in the heap, and we have to do this operation. Let's say this is the count, or we can say answer of ours, which will be returning basically, which gives us the count of times the operation we have applied. Okay, so for not actually for while, up to when we need to do this, up to when the pq dot top becomes is less than k, until then we need to go up, otherwise we just need to break out of the loop. So while pq dot top is less than k, what we need to do is um, we take the top two elements from the heap. So int uh, one value, where we can say value 1 is equal to what, pq dot top, we will pq dot pop, then int val2 is pq dot top again, it will be pq dot pop. Value 3 will be what we have to insert in this now, and what we have to insert is simple, that is this, that min of val1 and val2, and we need to multiply 2 with it, plus max of val1 val2. Okay, perfect. Now we will be pq dot push what, val3. Fine, and every time this operation is performed we will increment the answer by 1. So yeah, this will give us the result. It should, let's see now if it's fine. Priority queue long long, what's the array in this, value type, okay, maybe long long will not be good, maybe it doesn't identify long long, I'm not sure like if this is the thing. Okay, okay, I got it, this was a comma here. Okay, fine, we can remove this. That's what I was thinking, that it should actually. Okay, again, greater long long, value type, I'm not sure, let's see. mm, Priority queue, let's say out uh, min heap in C++. Okay, yeah, this is the max heap. Okay, greater comes at last, vector comes at second. So okay, fine, fine, fine. Here is a greater, and here it is as vector. Fine, fine. That was my mistake. Okay, well, to L should not be a capital. Anything else? I don't think so. Let's submit this. and overflow. Fine. If it's overflowing, then make it long and long. And in fact, we can do this for all of them. Okay. Use this test case and now run. Yeah, now it is working fine. Perfect. So yeah, this is one of the way of doing it. Second was the array sorting, which was obviously not optimal, and this was the optimal because we used the best data structure which can be used to retrieve the minimum out of a list or array, and also insertion is also logarithmic time. So that's the best we can do. So that's it.